Hello, this is Trevor Lynn. Today we are going to be making cookies, and within that, we're going to be exploring the Maillard reaction. So, just a little quick outline, just a little recipe. I'm pretty sure I'll put the recipe somewhere over here while I read it out. But first we're going to preheat the oven to 360 degrees Fahrenheit, and then we'll be preparing all the ingredients. Putting together the flour, baking powder, baking soda, and salt, putting them in a bowl, stirring, melting the butter, um, and then we'll be putting the melted butter in a large bowl, whisking the sugars and the butter together. Then we'll add eggs and stir in some vanilla extract, and then throw in the chocolate. And after that, just chuck them in the oven and let the chemistry do its magic, right? So, the chemistry though is, well, I guess what's more important to talk about. So first we have the Maillard reaction. So what is it? So it's a non-enzymatic browning. It can occur spontaneously, but it's very, very slow when it does. So therefore, heat needs to be added in order to speed up the reaction rate. So at high temperatures, it creates a reaction to where not only does it give it the cookie its brown color, but it also gives it a distinct flavor slash aroma. So this doesn't occur on just cookies. It also occurs on steak, breads, dumplings, toasted marshmallows, etc. And it all depends on the chemical constituents inside the ingredients and the temperature and also the amount of time you're cooking it at. So, there are hundreds of Maillard reaction products. We have, just for example, oxazoles, furanols. They give off different types of sweets and aromas and tastes, if you will. But the thing that we can see instead of taste or smell is the melanoidins, which is made in the Maillard reaction. These are the polymeric substances to give the food the brown color that we see. So the general mechanism, the Maillard reaction occurs between a reducing sugar and an amino acid. So just for example, we have a glucose reducing sugar, which serves as the electrophile. And then here we see a amine group attacking the electrophilic glucose, the carbonyl carbon, right here. And, it forms into a Schiff base, an amine right here. We learned about that in the reductive animation experiment earlier this year. And then it goes under an isomerization. And it needs heat, so you'll see this in the oven. And this forms the important Amadori product. So this is what is the main intermediate in the reaction, in the Maillard reaction. So this isomerizes into a 1,2-ene-aminol, and then it is protonated under acidic conditions. It also works under basic conditions, but it's a bit different. The mechanism is a bit different. And it goes under a dehydration reaction to become a 2,3-enol. And the protonated amine leaves off as a leaving group. And it forms a dicarbonyl. So this is the most important intermediate in the Maillard reaction because the dicarbonyl reacts with another amine group, whatever is in the ingredients of the cookie, another amine group, and it'll form an aldehyde, and hundreds and hundreds of different types of amines and dicarbonyls with different R groups all react together to form flavor compounds and our special melanoidins that give the brown color. So the reaction between the dicarbonyl and the amines also, it's very complex because there's so many different molecules that can undergo this Strecker reaction, which is the reaction between the amine group and the dicarbonyl. You may see carbon dioxide and water release. You may see water being absorbed and used up and consumed. So that the release of CO2 also contributes to the rise of the dough. It's not the main factor as to why cookies rise, but it helps. So hundreds of reactions can be done because there's hundreds of different types of dicarbonyls and molecules that can be reacted within this cookie making process, and the result is tons of different aromatic complex products that result in the brown color and different types of aromas and flavors that make the cookie a cookie or a seared steak a seared steak. So we will also see a caramelization occur, the browning of sugars. It's also a non-enzymatic type of browning too. It occurs at high temperatures at 350 degrees Fahrenheit. So we'll see that as well in our cookie making experiment. And it involves the breakdown of just sugars to produce polymers that have a brown color and nutty flavor. So we'll also see that, but we're not going to be exploring that today. Just the Maillard reaction. So yeah, that's the chemistry behind it, and I'll walk you through the chemistry and the recipe process right now. Let's go. First, we will be preheating the oven to 350 degrees Fahrenheit. 360, yeah.
360?
Yes, ma'am. We're going to melt the unsalted butter, 1 cup, so 8 tablespoons worth of butter. So next thing we got to do is we got to whisk together the flour, baking powder, baking soda, and salt. All right, that is 3 1/4 cups of all-purpose flour. All right, 1 1/2 teaspoons of kosher salt. And 1 1/4 teaspoons of baking powder. Yo. Mom? All right, found it. 1 teaspoon of this bad boy, baking soda. That's okay. All right, so now that it's all together, we want to check on the butter because next we're going to pour in the melted butter and then whisk in the sugars. So let's check on that butter. All right, the butter looks done and it's kind of bubbling a little bit, which is what you don't want. So we're just going to pull it out right now. We're going to put it in a bowl, or in this bowl, sorry. We're going to mix it. We're going to whisk it in. We're going to whisk in the sugars. So we just put in 1/2 cup of granulated sugar, and next we're going to put in 1 1/2 cups of brown sugar. And here goes in the brown sugar. All right, 1 1/2 cups in. And it looks pretty dry, I'm not going to lie. But next we're going to add 2 eggs, 1 at a time. I am making a mess in the kitchen. Luckily, we're not graded on that, I think. Hopefully 2 teaspoons of vanilla extract will not make this bad boy dry, because it looks as dry as the Sahara Desert right now. All right, that's 2 teaspoons of vanilla extract, and we're gonna keep stirring it in. The eggs are the proteins or the amine groups that will be participating in the Maillard reaction. All the carbohydrates, all the sugars will be participating in the Maillard reaction that we'll see later. But for now, we're just hoping that this turns out to be somewhat looking like dough. Mom, is this supposed to be looking like this? Did I do something wrong? Because I don't know about you, but this doesn't look like dough. Okay, apparently I'm not very smart. It's supposed to be looking like this, so I'm doing something right actually. Put in these bad boys now, the chocolate that makes chocolate chip. So it'll participate in the Maillard reaction and caramelization as well. So now we're just gonna keep mixing. Mom.
What?
For sure. So I guess I'm not a bad baker. I'm just one of the worst mixers you'll meet. So I got that going for me. Maybe I should have gotten a bigger bowl. To be clear, this is my mom's friend's recipe, who she swears is the best cookies that has ever graced this earth. So we're trying it. Mom? Yeah. Mom?
Why do you say mom?
You know what? That's a great idea. I never thought of that. That makes a lot of sense. I like your thinking. Maybe you should be in my chemistry class. So we are lining this with parchment paper.
Nope. No. Nope.
Thanks, Mom. We are going to try to put these bad boys together into real cookies. The recipe calls for 24 cookies, but we're gonna make 12. So here's the dough, very crumbly.
Yeah, there'll be 3 for each pile.
Mmm, I got it. I can bake. I can bake. All right, so it's gonna get more brown than this because of the Maillard reaction and caramelizing.
Two hours later.
Done? All right, we're gonna cook these in the oven for 10 to 12 minutes until they're lightly cracked and golden. All right, now that we transferred to the wire rack, we're gonna let it cool and solidify, and then we're gonna go for the taste test. It's still soft, but you can really tell that there's a clear browning on the cookies, whether it's due to caramelization or the Maillard reaction. Our participant for this study is Mother Lynn. Do you feel the Maillard reaction coursing through your veins?
Sure.
1 out of 10, rate it, go.
8. I think we need to cook it a little longer, but it's soft though.
Let's go. We'll take an 8. We'll take an 8. All right. Let's try another participant. All right, baby B, what do you think, dude?
Yeah, what the?
Do you feel the organic chemistry in that?
Mm-hmm.
You feel the molecular bonds?
Taste the glucose.
Oh yeah, look at that. Look at that.
Science.
Science, man.
7 out of 10.
7.
Take that C. You pass.
All right, and that is the making of a cookie and the Maillard reaction. Hope you enjoyed. All right, take care. Mom?